Hello everyone and welcome to week 3. This week we're going to talk about system configuration and we're going to talk about assembly. Well, one of the things I wanted to mention this week before the lecture begins, there is assignment work that's in the assignment folder, and basically all this week is just doing assessments to Ucertify. So please let me know if you can't connect to Ucertify. I see half the class is already connected perfectly fine. The other half may be having problems. Please let me know beginning of the week. Don't wait until Sunday, the day before assignments due, to let me know, because then that puts me in a predicament. I like to get it done and over with early in the week to help you guys out, because that doesn't allow you enough time to complete the assignments. So please reach out to me. Alright, we're going to start with week 3 on the system information. So let's see real quick. The system configuration, this week you're going to discuss, you're going to learn about the configuration changes to your computer, the importance of a BIOS, what is a BIOS, how to replace a motherboard battery, talking about jumpers within a motherboard, and so forth. So we'll get started, and you can kind of follow along within the chapter as well. So an overview, a configuration overview is basically installing, configuring a motherboard. So in this case, when you're installing a motherboard, if you look on illustration figure 3.1 on page 94, there is jumper pins 1, 2, and 3. So okay, so when you get, there's two types of motherboards. So if you're installing, let's say that you're building a new computer, you have a case and you want to install a motherboard. In order to install the motherboard, it requires you to have access to the jumpers. So most older computer motherboards had jumpers, and some of them have automatic jumpers. Example in 3.1, this is so important because if you set the wrong jumper, you could easily fry the board. And say you paid $170 for that motherboard, it's gone. And if you take it back to the manufacturer, they're not going to give you your money back because you blew the jumper. So what I highly recommend is something. I used to build computers in the past, in the late 90s or early 2000s, when it was pretty popular, and I'd go around and build custom computers for clients of mine. And the thing what I would do is I'd specialize. I ran into this problem. I was using these ATX boards, and they were good, and they had jumpers, and they worked fine. But then I ended up discovering this one motherboard called Gigabyte. They were the first ones at that time that was doing automatic jumpers. You didn't have to set the jumper on the board, which was awesome. And I always recommend to go with them because it's all automatic and it makes things work. Once you plug certain things into place, such as the power supply, and you get your CPU and all that stuff installed, you're good to go. So just a recommendation, I would go with those types of motherboards. They're called Gigabyte. They're one of the more popular ones. Alright, moving on here. So BIOS overview. Hopefully some of you have already heard about BIOS, but if you haven't, it's no big deal. So it's the basic input-output system. It's important because it's basically the software that is installed on the motherboard itself. So let's say that you have a Windows machine, a PC, whatever the case is, and you go to boot it up. You'll get you'll see options sometimes on there. It says F1 for setup. You might see F2 for setup. You may see delete. You may see escape. But you have these options. Usually those are the 3 options that you'll see. Sometimes F10 for setup as well. What that does is by selecting that, it brings up another menu, which is called the BIOS menu. And I kind of took a snapshot here because I run a PC or Windows, so I don't, or PC or a Mac, I mean, so it's not really gonna do me any good to show you what that is. So looking at this right here, or this would kind of an example of what the BIOS looks like in a sense. As you see here, what am I doing here? 1 second, like that. All right, so going back to this, as you see here with the BIOS here, it kind of shows you an example of what the BIOS looks like. So you're able to go in there and you're able to make some selections. You're able to choose the voltage control, the BIOS features, make changes to the chipset. Let's say that, for example, let's say that you're booting up your computer and you want to reinstall Windows, for example, and you're using a CD. Well, if you have the CD in the disk drive and it just goes straight to Windows, you want it to go up and ask, hey, do you want to boot from the CD? So this would be a location that you would go. Is you would go in here and you would make your selection on the drive and say that you want to boot directly from. Actually, it'd be in advanced. It would be in advanced BIOS features. You would go. I'm sorry. It'd be in PNP PCI configurations. You would go into that area and you would select boot from, say, CD drive. Say you want to boot from a thumb drive, USB. You would make those selections so that when you you save it and restart the computer, it'll do a warm boot, and that's where it'll check first. So if you have CD drive, it'll check that CD drive and boot from there. Or if you have USB, it'll check that USB and boot from there. That just allows you to install your software, such as your operating systems and so forth. So that is with Windows. Now Apple, totally different story, but this chapter is not about Apple. All right, so moving on, kind of just going to hit some of the really important topics here. Flash BIOS is your allows the changing of the BIOS without installing new chips or chipsets. Common computer BIOS manufacturers such as AMI, American, Megatrends, or Phoenix, those are more the popular ones. After a BIOS is upgraded and downloaded from the internet, execute. So you basically could just download an executable or a file from that manufacturer before you before you actually have to do anything with it. Like I said, I'm just going to hit some of the important topics here. Another thing is a UEFI. What is a UEFI? It's a Unified Extensible Firmware Interface. Sometimes it's seen as EFI. So in the interface between an operating system and firmware, which could be the traditional BIOS or UEFI, could replace the BIOS. The traditional BIOS has roots in the original PC. The BIOS always checked the certain things such as keyword before allowing the system to boot. A traditional BIOS made configuring kiosks and touchscreen technologies difficult. So with the UEFI, you can boot into an environment which includes the configuration parameters, but unlike an original BIOS environment, you can use your mouse. So basically, in a nutshell, it may be a little bit more usability. So if you're using a BIOS, it's all command, or well, command mouse, not mouse, but up and down arrows on your keyboard. You know, previously, before Windows interface environment existed, and then within this environment, it allows you to see something more additional to it. Allows you to kind of move around and so forth. If you turn to page 98 in your book, BIOS configuration settings, kind of review this table and get familiar with, because I'm not going to read through all this, get familiar with the different options that are in there. It has system information, it tells you displays general information such as processor speed, and so forth. But as you go down here, you'll see one that says boot sequence, boot drive order. That's what I was talking about, how you want to boot from. You have video options, so you can make video changes. Be careful with that because you might have two different video slots. You might have the one that come with the motherboard. You might have one that you install, say, in your AGP slot. And you got to be careful you're not using the wrong one and causing problems. It talks about virtualization, which is very, very popular nowadays. Drive encryption. Also in the past, you used to be able to set passwords on here as well. So what that would mean is when your computer starts up, you could set a password, not like in Windows. You know how like Windows has a password? You know, you have to enter username, password, or just your password nowadays, because it has your profile. But your actual computer, you could set a password to, so you can't even get to the operating system without having that password. But be careful you don't forget that password, because there's a lot of challenges that happen when you have to do that. So moving on to Cmos memory. So as you see here, it's complementary metal oxide semiconductor memory. Its settings change in the system's BIOS that are recorded and stored in Cmos. So Cmos is like this little battery that is on your I wish I had an image of it. Let me see if there's an image in the book here. But it looks like if anyone's ever seen a watch battery, so those of you who might have a watch, still wear watches, they have these really small batteries. Or if you, let's see here, if any of you have Apple TV remotes uses the same watch battery, like a watch battery, and that's basically what the CMOS looks like. It looks like that. It's very easy to understand when you see it. You're like, okay, I know what that is. But it requires a small amount of power provided by a small coin size. And because of the small coin size lithium battery, when the system is powered off, the memory holds settings configured through the BIOS. Part of BIOS is software routine that runs after the computer is turned on, checks the CMOS for information about the components are supposed to be installed and what components are supposed to be tested. So think about this. All right, before you go to sleep at night, you retain certain information. So let's say that you wake up in the morning, you know that you have an appointment, a doctor's appointment at 9 o'clock, and at your doctor's appointment, they're going to check A, B, C, and D. So you know those things are going to happen. But when you go to sleep at night, you're sleeping and nothing's going on. But when you wake up in the morning, you know right away that, hey, I have to get ready. I have to go to the doctor's at 9 o'clock, and the doctor's going to check A, B, C, and D. That will be an example of CMOS because it's retaining that information. It's waiting for someone to provide feedback. Maybe your parent or your mom, or your dad, or your spouse or whatever. It's like, hey, what are you supposed to do today? And you're like, oh, I'm supposed to do blah, 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 blah. That's an example of CMOS because it's just something that once it's powered off and powered back on, it retains that information. So hopefully that gives you a better example. All right, so talking about motherboard batteries. So the most common battery used today is a CRT032. Forget about the model name. Just remember the most popular one is a lithium battery because its model numbers change very frequently, which is about the size of a nickel. So if you look in figure 3.6, you'll see the battery also looks like a watch battery as well. If you cannot find a motherboard battery, refer to the motherboard or the computer documentation for exact location. So if you look in figure 3.6, you'll see the battery. No battery lasts forever. High temperatures or powering devices, it uses the batteries on and off battery lifespan. But however, they say 3 to 8 years, but to be completely honest with you, nowadays the computer is outdated within 5 years. So it'll probably never go bad unless you keep the computer for 15 years and eventually something's going to happen. But this is what I tell people, that when you're going and purchasing a computer, think smart about what you want. If you can build a computer yourself, that's the best idea doing it, because you can build what you want to build. You could buy a big case, you could buy a small case, you could customize it how you want. Let's say that you're building on a budget and you can't afford to go and buy this $1,200 computer. Fine, you could find a cheap motherboard, you could find a cheap CPU, you could find cheap stuff. I'll give you an example. Like 10-15 years ago when I was building computers, I would build them for family members, and I would do the same thing. I'd build them a cheap system where they went to the store and they bought a Dell at the time. It cost $1,500. I built them a system for $350. But what was nice about that, the way that since you customize it, let's say you run into some extra money and you're like, hey, you know what? I want to upgrade to this and that. No big deal. You could take it apart and upgrade it, because when you buy the motherboard, you make sure that you're able to upgrade on certain things. So let's say you want more CPU. No big deal. You take the CPU off, put a new one on. You want more memory? Awesome. You could do that. So remember that when you're wanting to purchase a computer, you have that ability. So that's kind of off topic of what I'm talking about, but kind of give you an example. So other things are IRQ, very important, interrupt requests. A lot of this stuff is done automatically now, but it is very important to understand how IRQ works. Basically, it is a number that is assigned to an expansion adapter or port. So orderly communication occurs between the device or the port and the processor. So for example, when a key is pressed and a mouse is moved, the keyboard has the highest priority based off that IRQ number. So I would recommend going to page 103, looking at 3.8 IRQs and device managers. go in your computer and go to the device manager. It's under your control panel, and when you go to control panel, there's an advanced settings. Click on advanced settings under, if you're using Windows 7 or 10, and choose. I'm not real familiar with Windows 10. I haven't used it, but I'm just assuming it's the same thing. Windows 7 or Windows 8. Go to device manager, view resources by type, and you'll get the same example as you have in 3.8 here. You'll see what's on what IRQ and so forth. You can make those changes as well, but be careful when doing so. Let's see here. Just trying to hit some important topics. Alright, so we have, if you look on page 105, it talks about device manager error codes. These are important because, you know, when your computer boots up for the first time or second time, whatever the case is, there's certain codes that you get. So these codes are very important to remember. So you might see those on a quiz. Hint, just a little hint that you might want to see that some other time. I might say, what's the code 14? You'll be like, oh, that's a device requires a system restart. So remember those are very important. PCI interrupts. When a PC boots for the first time, the OS discovers the AGP, which is used for solid-state graphics cards. PCI or PCIe, which are just basically adapters on the motherboard, allows for some type of device to plug into it. And devices are present and that the system resources each one needs. The OS allocates resources such as the interrupt, adapter, device, if the adapter or device has ROM read-only memory or software is allowed to execute during the process. So read a little bit about that on 105. Let's see here, going through. Those are pretty much the important things on Chapter 3. So summary is, we talked about the system flash bias. We talked about the Uefi bias. We talked about the interrupts, PCI cards, the system device manager. And what I would do is I'd review the key terms at the end of the book on chapter 1, page 111. Also review the questions. Now this is not necessary, but just see if you can answer. When would a technician flash a BIOS, or what is the effect of a setting of an administrator password and BIOS? You know, so I talked about setting a password in the BIOS. What is the name of the Windows device database where Windows configuration information is stored? Just see if you can answer those questions, and that'll be very helpful. You don't have to do any of these labs in the book because we're using U-Certified. And this is Chapter 3, and we'll discuss assembly and power in Chapter 4. Thanks for your time.